So this section is about rational exponents. Remember, rational basically means fractions. It incorporates all the other numbers too up until that point, but that's where fractions come into that set of numbers. So whenever we talk about rational numbers, we think about fractions, but this is exponents. So yes, what that means is we're going to have fractions in our exponents. Okay, so let's talk about if I have 5 squared. This is an exponent problem. And this tells me that I need to multiply the base by itself the exponent number of times. Again, multiply the base by itself the exponent number of times. That's what an exponent problem is. So in this case, that would mean 5 times 5. I multiply the base, which is 5, by itself, the exponent number of times, which in this case is 2, and we get 25. But what happens if I have something like 25 to the 3/2? Can I multiply the base, which in this case is 25, by itself 3/2 times? How is that even possible? Well, here is how it's possible. This exponent, and remember the opposite of exponents is roots. So the numerator stays as our exponent. Let's do something different for this. And our denominator becomes our index. I'm going to show you how this works. So when we have 25 to the 3/2, the next thing I need to do to be able to do anything with this is write it in radical form. This is exponent form because it has an exponent. And this is radical form. Radical, I can't talk and spell. Form, because it has a radical. Okay, so 2 is in here in the index. It's invisible because we don't write 2. And then, what's going on? Okay, 25 to the 3rd. Well, now I'm going to take what's inside the parentheses. What is the square root of 25? Well, that's 5. And I still have to the 3rd on the outside. And so that 5 to the 3rd is 5 times 5 times 5. 5 times 5 is 25 times 5 is 125. Now, somebody is going to say, why don't you just write it like this? And here's the reason why. Because technically, what I have to do first now is what's underneath the radical sign, which is 25 to the 3rd. So that's 25 times 25. I'm going to be bad, even though I tell you guys you're not supposed to, but I want to get a lot of these in here, so I'm just going to do it on the calculator. Times 25, and that's 15,625. So now I have the square root of 15,625, and now I need to do my prime factorization. So 1 and 5 is 6, and 6 is 12, and 12, 13, 14, and 5 is 19. So 3 won't go into it, but I know 5 will because it ends in 5. So divide by 5. 3125 divide by 5 divide by 5. I'm just trying to find out what the square root of 15,625 is. Oops, 5 times 5. And my index tells me that I have to have groupings of 2. Everybody got circled, so I take 1, 5 from each of these. 5 times 5 times 5 is 125. So I get the same answer, but how much more work was it to do it by doing 25 to the third first and then finding the square root of 15,625, as opposed to finding the square root of 25 first and then taking the cube of that. In the first incident, I didn't even have to use a calculator. And you aren't allowed to use calculators, so you might want to consider about this. All right, let's do some more. 27 to the 2/3. Well, 3 is my index. Remember, the denominator is always your index. And the numerator is your exponent. Okay? And so 27 squared. Well, the cubed root of 27 is 3, and 3 squared is 9. See how easy that is? Okay, let's do negative 16 to the 3/2. Now, with negatives like this, I need to be really careful. In this case, the only thing that is the base of my exponent is a 16, not the negative. So that negative needs to stay on the outside when I write this in radical form. So the square root of 16 is 4, and 4 to the third is 64, and negative times a positive is a negative. Okay? Let's do this guy. Negative 64 to the 2/3. Now, here's the thing. This whole thing, because it's in parentheses, negative and all, is my base of the exponent. So that means it has to go underneath the radical when I write this in radical form. Well, let's see. I need the cubed root. I know what the square root is. That's 8. But what's the cubed root? So 2 times 32, 2 times 16, 2 times 8, 2 times 4, 2 times 2, and I need 3. Look at that. 2 times 2 is 4. And so the cubed root of negative 64 is going to be negative 4, and then I square that, and so my answer is 16. Now, I could have something like 32 to the 1/5. Well, again, that denominator is my index, and the numerator is my exponent. Well, we don't write 1 exponents, so I just write it like this. Then I just need to figure out what the 5th root of 32 is. So 2 times 16, 2 times 8, 2 times 4, 2 times 2, and I need 5. 1, 2, 3, 4, 5. So the answer is 2. Now, once you know that, if you guys are reading the book, you're going to have trouble because the book wants you to write the other ones, the ones I was doing to begin with, in terms of something like this one with a 1/5. It's way harder. Don't do it. Just do what we've been doing here. What if I had something like 1/27 to the 1/3? Well, first I'm going to take the 1/3 and distribute it into each of these because they're being divided. I can only distribute it in if it's being divided or multiplied. So this is 1 to the 1/3 over 27 to the 1/3. And now I can put the numerator and the denominator in radical form. Any root of 1 is 1. Just think about it the other way. What's 1 squared? 1. 1 cubed? 1. 1 to the 4th? 1. 1 to the 5th? 1. What's 1 to the 57th? 1. So any root of 1 is also going to be 1. Any root of 0 is also 0. So the cubed root of 1 is 1, and the cubed root of 27 is 3. I'm done. Okay? So when we are writing these things, we want to be real careful also about exactly what is and what is not our base. In this case, just the x. The base is what is the exponent is immediately next to. So in this case, it's just the x. And so the x is the only thing that gets to be written in radical form. So this would be 14 times the cubed root of x squared if we were writing it from exponent form to radical form. Now, what if we were asked to write it from radical form to exponent form? Well, going back the other way, our index becomes our denominator, and our exponent becomes our numerator. So when I write this from radical form to exponent form, 1 is my numerator because 1 is the exponent there, and 2 is my denominator because that was my index. Okay? Let's just look at something like this again. The 4th root of 9 to the 8th. Well, instead of doing it like we did before, let's put this in radical form. Exponent form. Remember, the exponent becomes my numerator, the index my denominator. Now, what is 8 divided by 4? Well, that's 9. And what is 9 squared? 81. I'm done. Now, remember when I said to you, if I have something like the 4th root of 4 to the 4th, let's make it 3 to the 4th. Too many 4s. When this and this match, this falls out as my answer. Well, let me prove it to you now. If I change this into exponent form, I get 4 over 4. And what is 4 over 4? Anything over itself is 1. And what's 3 to the 1st? Just 3. I'll do it one more time. The 8th root of x to the 8th. Well, if I write it this way, that's x to the 1st, so it's just x. Just remember, though, when this and this match, the base of the exponent falls out as your answer. Next, I'm going to do negative exponents.